Welcome to the course Fundamentals of Physics 1, and in this video I am going to talk about elastic collision in one dimension. Consider two elastic bodies of mass m1 and m2 moving in a straight line, that is along positive x direction on a frictionless horizontal surface. This is m1 and m2 moving in a straight line, and u1 is the initial velocity of mass m1 and u2 is the initial velocity of mass m2, and after collision the final velocity is v1 for mass m1 and v2 is the final velocity of mass m2, right? Here mass m1, the initial velocity before collision is u1 and the final velocity after collision, that is v1, and for mass m2 the initial velocity before collision is u2 and the final velocity after collision is v2. So in order to have collision, we assume that m1 moves faster than m2. Suppose if m2 is faster or both are in same speed, that is the collision does not occur. So we assume m1 is faster than m2. So for elastic collision, the total linear momentum and the total kinetic energy of two bodies before collision and after collision must remain same. So total linear momentum before collision is equal to total linear momentum after collision, and total kinetic energy before collision is equal to total kinetic energy after collision. Okay, first we are going to find the total linear momentum. Okay, first the momentum for mass m1 before collision is, we know that momentum is equal to mass into velocity, p is equal to mv. Here before collision for mass m1 the momentum is pi1, that is I is the initial, right? pi1 is equal to m1 u1. m1 is the mass of the first body and u1 is the initial velocity of the first body, and mass of the second body is m2 and initial velocity is u2. So the momentum is pi2 is equal to m2 u2. So from this we can find the total linear momentum, that is momentum of the first body plus momentum of the second body, that is pi1 plus pi2. We can get pi, that is equal to m1 u1 plus m2 u2. This is the momentum for before collision. Now we are going to find the total linear momentum after collision. So after collision the momentum of the first body, that is pf1, f is the final, is equal to m1 v1, and for second body the momentum pf2 is equal to m2 v2. So total linear momentum after collision is pf1 plus pf2, that is pf is equal to m1 v1 plus m2 v2. And from the law of conservation of linear momentum, the total momentum before collision is equal to total momentum after collision. So we equate these two, that is pi is equal to pf, that is before collision momentum before collision is equal to momentum after collision. We equate these two, we get m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is equation number 1. Okay, now we just rearrange this equation, that is we can take this m1 v1 left hand side, we get m1 u1 minus m1 v1 is equal to m2 v2. You take this term to right hand side, that is minus m2 u2, and here m1 common, you take this outside, so m1 into u1 minus v1 is equal to, here m2 is common, so you take this outside, so m2 into v2 minus u2. So total momentum before collision is equal to total momentum after collision. Okay, now we are going to find the kinetic energy. For elastic collision, total kinetic energy before collision is equal to total kinetic energy after collision. So now we find the total kinetic energy before collision and total kinetic energy after collision. Okay, we know that the kinetic energy is equal to 1 divided by 2 mv square. Here before collision, for the first body, the kinetic energy Ke I1 is equal to 1 divided by 2 m1 u1. m1 is the mass of the first body and u1 is the initial velocity of the first body. And for second body, Ke I2 is equal to 1 divided by 2 m2 u2 square. m2 mass of the second body, u2 is the initial velocity of the second body. So from this we can find the total kinetic energy, that is Ke I1 plus Ke I2. We just add these two, we get Ke I is equal to 1 divided by 2 m1 u1 square plus m2 1 by 2 m2 u2 square. This is the total kinetic energy before collision. Now we find the total kinetic energy after collision. So for first body, the total kinetic energy after collision is equal to 1 divided by 2 m1 v1 square. v1 is the velocity, final velocity of the first body. And for second body, 1 by 2 m2 v2 square. v2 is the final velocity of the second body. So from this we can find the total kinetic energy. We just add these two, we get kinetic energy Kef is equal to 1 divided by 2 m1 v1 square plus 1 by 2 m2 v2 square. Okay, we know that for elastic collision, total kinetic energy before collision is equal to total kinetic energy after collision. So we equate these two, that is before collision is equal to after collision. We will get this. This is equation number 3. Okay. Now here 1 by 2 m1 u1 square and here this b1 square. You take this term left hand side. So we get minus 1 by 2 m1 v1 square is equal to, you take this u2 term to right hand side, we get 1 by 2 m2 v2 square minus 1 by 2 m2 u2 square. Now here 1 by 2 m1, 1 by 2 m1 common, so you take this outside. So 1 by 2 m1 into u1 square minus v1 square is equal to 1 by 2 m2. Here 1 by 2 m2 common, so you take this outside. 1 by 2 m2 into v2 square minus u2 square, right? Here u1 square minus v1 square, you expand this term. We know that a square minus b square is equal to a plus b into a minus b. So you expand this, we get m1 into u1 plus v1 into u1 minus v1 is equal to, here we cancel this 1 by 2, 1 by 2 and m2 into v2 plus u2 into v2 minus u2. This is equation number 4. Now we divide this equation number 4 by 2, that is, this is the kinetic energy. So divide this equation by the equation of momentum. We get m1 u1 plus v1 into u1 minus v1 divided by m1 u1 minus v1 is equal to m2 v2 plus u2 into v2 minus u2 divided by m2 v2 minus u2. Now you cancel this m1 and u1 minus v1, you cancel this, and here also we can cancel this m2 and v2 minus u2. We get u1 plus v1 is equal to v2 plus u2, and we just rearrange this equation, that is we can take this u2 left hand side, we get u1 minus u2 is equal to v2 minus v1. This is equation number 5. We just rearrange this, that is u1 minus u2 is equal to, you take this negative sign, you just rearrange, so we get minus v1 minus v2, that is the speed of the elastic bodies after collision has the same magnitude as before collision but in opposite direction. That is, here u1 minus u2, here v1 minus v2. So the magnitude are same, but this opposite sign, this negative sign indicates it is in opposite direction. Okay. Now we rearrange this equation number 5 and we can find the velocities, final velocities v1 and v2. We just rearrange this equation. From this equation, v1 is equal to v2 plus u2 minus u1, and from this we can find v2 from the same equation, which is equal to u1 plus v1 minus u2. So this is equation number 6 and this is equation number 7. Okay. Now we are going to find the final velocities of v1 and v2. Now we substitute the equation number 6 in equation number 2, that is the momentum equation, right? Substitute this 6 in that equation. Equation number 2 is m1 into u1 minus v1 is equal to m2 into v2 minus u2. You substitute this b1, that is v2 plus u2 minus v1. In this equation, we get m1 into u1 minus, this is the v2, that is v2 plus, sorry, v1, that is v2 plus u2 minus u1 is equal to m2 into v2 minus u2. And m1 into u1 minus, you multiply this negative sign, that we get u1 minus v2 minus, that is minus into plus minus, and minus into minus plus, that is plus u1 is equal to m2 into v2 minus u2. You multiply this m1 with this term, we get m1 u1 minus m1 v2 minus m1 u2 plus m1 u1 is equal to m2 v2 minus m2 u2, right? And here m1 u1, here one m1 u1, so 2 m1 u1 minus and m1 u2, and you take this m2 u2 to left hand side. Now we take this v in one side and u terms in another side. So m2 v2, you take this m1 v2 to right hand side, because we are going to find the velocity v2. So you take the v2 terms into one side. So 2 m1 u1, here m2 u2 u2 common, so you take this outside. So m2 minus m1 into u2 is equal to, here v2 is common, so you take outside, so v2 into m1 plus m2. From this we can find v2. v2 is equal to 2 m1 u1 divided by this m1 plus m2 plus m2 minus m1 divided by m1 plus m2 into u2. This is the velocity for second body, that is v2, final velocity of the second body. Okay, now we are going to find the final velocity of the first body, that is v1. Now we substitute the equation number 7 in 2. So the second equation is m1 into u1 minus v1 is equal to m2 into v2 minus u2, and the seventh equation is v2 is equal to u1 plus v1 minus u2. Now you substitute the seventh equation in equation number 2, we get m1 into u1 minus v1 is equal to m2 into v2. You substitute this value, that is u1 plus v1 minus u2 minus u2, and multiply this m1. So m1 u1 minus m1 v1 is equal to, and multiply this m2. So m2 u1 plus m2 v1 minus 2 m2 u2. And now we take the u terms to left hand side and v terms to right hand side. So here m1 u1, and you take this v1 to right hand side, and this m2 u1 you take this into left hand side, that is this is positive. So when you take this into left hand side it becomes negative, right? So minus m2 u1 and here 2 m2 u2. So you take this into left hand side, so it becomes positive. So plus 2 m2 u2 is equal to here m2 u1 and this m1 v1. You take this to right hand side, so it becomes positive. So m2 v1 plus m1 v1 and here u1 common, so you take outside. So m1 minus m2 into u1 plus 2 m2 u2 is equal to here v1 common, so you take outside. So v1 into m1 plus m2. From this we can find the velocity v1 is equal to m1 plus m2 divided by m1 plus m2 into u1 plus 2m2 into m1 plus m2 into u2. This is the final velocity of the first body. Okay, now we discuss some cases. First case, when bodies has the same mass, that is m1 is equal to m2, both are in same mass. So the equation number 8, which becomes, that is 8 is equal to, equation number 8 is v2 is equal to 2 m1 u1 divided by m1 plus m2 plus m2 minus m1 divided by m1 plus m2 into u2. This is equation number 8. Now we put m1 is equal to m2, that is the two bodies have the same mass. So we put this as m. So 2 m1, that is m, divided by m1 plus m2, that is m plus m, that is 2m into u1 plus here m2 minus m1, that is m minus m, which is 0. So this term becomes 0. So v2 is equal to, you cancel this 2m 2m, we get u1. So v2 is equal to u1. And in equation number 9 we put m1 is equal to m2 is equal to m. So in the 9th equation, v1 is equal to m minus m, that is 0. This term becomes 0 plus 2 into m2, it is m, 2m divided by m plus m, that is 2m into u2. So you cancel this 2m, we get u2. So v1 is equal to u2. So this equation shows that the two equal mass collide each other. After collision, their velocities are exchanged, that is v2 is equal to u1 and v1 is equal to u2. That means after collision, the first body moves with the initial velocity of the second body and the second body moves with the initial velocity of the first body. And case 2, when two bodies have the same mass, that is m1 is equal to m2 and the second body is at rest, that is u2 is 0. u2 is the initial velocity of the second body, it is in rest, it is at rest. So u2 is equal to 0. Now we substitute this in the equation number 8 and 9. We get, first equation number 8 is v2 is equal to 2m1 divided by m1 plus m2 into u1 plus m2 minus m1 divided by m1 plus m2 into u2. You substitute this, m1 is equal to m2, which is equal to m, and u2 is equal to 0. We get here 2m1, that is 2m divided by m1 plus m2, that is m1 m plus m 2m into u1 plus this u2 is 0. So this term becomes 0. So v2 is equal to, you cancel this 2m and 2m, we get v2 is equal to u1 and we put this m1 is equal to m2, which is equal to m, in equation number 9 and u2 is equal to 0. This is the equation number 9. v1 is equal to m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2. So we put m1 is equal to m2 is equal to m and u2 is equal to 0, we get b1 is equal to m1 minus m2, that is m minus m, 0. So this term becomes 0, plus 2m divided by m plus m, that is 2m into 0. This term also becomes 0. So b1 is equal to 0. So this equation shows that after collision, when the first body comes to the rest, that is v1 is 0. After collision, the first body comes to the rest and second body moves with the initial velocity of first body. Second body, the velocity of second body is v2. It moves with the initial velocity of first body, that is the initial velocity of first body is u1. So the second body moves with the initial velocity of the first body, right? Then case 3. So let us consider the first body is much lighter than the second body. So the first body is very small than the second body. So m1 is less than, very lighter than m2. So m1 divided by m2 is less than 1, which is approximately equal to 0. m1 divided by m2 approximately equal to 0, and the second body is at rest, that is u2 is 0. Now we dividing the numerator and denominator of equation number 8 and 9 by m2. So we divide m2, we get v2 is equal to 2m1 divided by m2 divided by m1 plus m2 divided by m2 into u1 plus m2 minus m1 divided by m2 the whole divided by m1 plus m2 divided by m2. We just dividing the numerator and denominator by m2, we get this equation. Now we split this part, that is m1 plus m2 divided by m2. We can write this as m1 by m2 plus m2 by m2, and here also m2 by m2 minus m1 by m2, and here m1 by m2 plus m2 by m2, and here m2 cancel, here also m2 cancel, here this m2 cancel. So you can get v2 is equal to 2m1 divided by m2 the whole divided by m1 by m2 plus 1 into u1 plus here 1 minus m1 divided by m2 the whole divided by m1 divided by m2 plus 1 into u2. Now we put m1 divided by m2 is 0 and u2 is 0. So we get here 2 into m1 divided by m2, that is 0. 2 into 0 divided by 0 plus 1 into u1 plus here 1 minus 0 divided by 0 plus 1 into this u2 is 0, right? So this term is 0 and this term also 0. So v2 is equal to 0, right? Now we divide numerator and denominator of equation number 9 by m2. We apply the same procedure here also, that is this is equation number 9 and divided by m2, that is m1 minus m2 divided by m2 and m1 plus m2 divided by m2 into u1 plus this 2m2 divided by m2 the whole divided by m1 plus m2 divided by m2. We simplify this, we get v1 is equal to m1 divided by m2 minus 1 divided by m1 by m2 plus 1 into u1 plus 2 divided by m1 divided by m2 plus 1 into u2. Now we put m1 divided by m2 is equal to 0 and u2 is equal to 0. We get v1 is equal to m1 divided by m2. This term becomes 0. So 0 minus 1 divided by this is 0. So 0 plus 1 into u1 plus this u2 is 0. So this total term becomes 0. So v1 is equal to minus u1, that is v1 is equal to negative u1. So these two equations, that is equation number 14 and 15, which shows that the first body, which is lighter than second body, collide with the second body, returns into the opposite direction with the same initial velocity, that is v1 is equal to minus u1, right? u1 is the initial velocity before collision and v1 is the final velocity after collision. So it returns once the first body, which is lighter than the second body, collide with the second body, it returns in the opposite direction with the same initial velocity. This negative sign shows it is in opposite direction. Here the second body is heavier, so it is at rest. There is no changes in the second body, so it remains at rest after the collision. For example, when you ball throw at a wall, the ball returned back to the opposite direction, right? Here the ball is the lighter than the wall. The wall remains at rest. There is no change in the wall. The ball will return back in the opposite direction. This is the example when the first body is lighter than the second body. And next case, the second body is very much lighter than the first body, that is m2 is less than m1. That means m2 divided by m1 is less than 1, which is approximately equal to 0, and the second body is at rest, right? Here dividing numerator and denominator of equation number 8 and 9 by m1. So we can follow the same procedure. In case 4, we divide numerator and denominator of equation number 8 and 9 by m2. Here in this case we are dividing the numerator and denominator of equation number 8 and 9 by m1, right? Because in case 3 the first body is lighter and here the second body is lighter. So we follow the same procedure and we can find the v2 and v1. So v2 is equal to, v2 is equal to 2 divided by 1 plus m2 divided by m1 into u1 plus m2 divided by m1 minus 1 divided by 1 plus m2 divided by m1 into u2, right? Now if we put m2 divided by m1 is equal to 0 and u2 is 0, we get v2 is equal to 2 divided by 1 plus this is 0. So this term, this is 0 into u1 and u2 is 0, so this total term becomes 0. So v2 is equal to 2 into u1. Now we are dividing the numerator and denominator of equation number 9 by m1. We get v1 is equal to 1 minus m2 divided by m1, the whole divided by 1 plus m2 divided by m1 into u1 plus 2 m2 divided by m1 divide the whole divided by 1 plus m2 divided by m1 into u2. Now we put m2 divided by m1 is equal to 0 and u2 is equal to 0. So we get v1 is equal to 1 minus this term is 0 divided by 1 plus this term is 0 into u1 plus the u2. u2 is 0, so the total term becomes 0. So v1 is equal to u1. So this equations shows that after collision the first body, which is heavier, moves with the same initial velocity. So the first body, that is v1, after collision the final velocity of the first body is v1, which moves the same velocity of initial velocity of the first body, and the second body, which is lighter, will move with twice the initial velocity. Here the final velocity of second body is v2, which is equal to 2u1. That means it moves twice the initial velocity, right? 2u1. So twice the initial velocity of the first body, right?